And welcome to this session, A Change in Mindset, Lessons Learned from Ditching the Metal. As you heard, my name is Simon Aronsson, and I've been working with tech for about 10 years now. And for the last couple of years, much of that time has been spent advocating cloud computing and DevOps practices, both in different organizations and to broader audiences, such as I'm doing today. And I'd like to start off a bit by talking about three major types of software architecture common in software development, and more specifically, server development. Likely, you all know them and have worked in a project with at least the first of them, but maybe even the other two as well. So, first off, can you guess what style I'm trying to describe here? Yeah. This is probably one of the most common approaches to software architecture ever. And the basic idea behind the monolith is that we take all our code and all our data and we just mash it together and compile it into one inseparable unit. And it's really convenient and easy and requires little to no work to get started. But as your project grows, it's likely that you see some issues that start to surface. For example, maybe you'd like to be able to deliver just a subset of your project as an application, containing only the parts your user is interested in. How do we accomplish that with a monolith? It is possible, but it might require a lot of changes to the existing code. Or suddenly, we might even have multiple teams working on the same product. Either these teams need to have clear siloed responsibilities, or you'll find yourself in the front of a release train, trying to integrate all changes into a working release candidate, and that's painful. And it's also hard when it comes to maintainability. Maybe you've changed one method in the authentication service. I'm sorry, but unless you've implemented some kind of plugin architecture or similar, you'll just have to suck it up and redeploy the project in its entirety, which requires downtime and effort. So next up, can anyone guess what this is? So as a reaction to this, among other things, the idea of microservices were born. And in contrast to the monolith, microservices are fine-grained, loosely coupled services organized around business capabilities. Microservices communicate through simple, lightweight protocols such as HTTP, messages, or events. Because of this, the microservice architecture does not impose any alignment between services in terms of programming language, peripheral software, or hardware. For many of us, that felt as quite an improvement over the monolithic approach. Suddenly, we were able to deploy independently, choose the language best suited to solve a problem, or for that matter, fully replace parts of the solution without interfering with operation of anything else. As long as our public interface or API remained intact, that is. And some of you who've been around for a while might still ask you what the difference is compared to service-oriented architecture. And there are two quite significant differences. The first one is that the microservice architecture, compared to SOA, usually don't have a common application or application service layer, but rather let each service or API keep their isolated runtime context, usually in some kind of container. And the second one, which I think many of you who have worked with SOA might appreciate and agree with me on, is that luckily enough, it usually lacks any ESB. The ESB, or Enterprise Service Bus in SOA, sort of served as a patch panel between applications where you kind of took all your tangled point-to-point dependencies and just put them in a black box where you didn't have to see them anymore. And for anyone looking at your solution from a holistic perspective, it looked really neat, but the eyesore was still there, just not visible for your architects or your decision makers. And if we take the microservice approach a step further, we end up with what we nowadays refer to as functions. And Instead of contextually grouping behavior together into a service, we split it out and let each behavior have its own function. Basically, every HTTP endpoint, job, or what have you, now becomes their own microservice. You want to create a purchase order? Awesome. There's a service for that. Or print your purchase order. There's a service for that as well. And with that out of the way, let's make sure we're on the same page regarding what it is we're actually talking about. When we talk about serverless, or at least when I talk about serverless, I don't mean it in a literal way, as in there are no servers, because there is always a server, but rather as in I don't want to have to worry about a server. I'd also like to point out that to me, running serverless isn't necessarily equal to running everything as functions. Functions is just one form of serverless, albeit probably the one that has gained the biggest momentum in recent years. Simply put, serverless for me is a hosting option where I may host my application, website, or engine without even having to reflect about the server that is running it. I'd argue that Azure App Services, Google Cloud Platform, or obvious Fargate, Google App Engine, sorry, all qualify as serverless, even though they're perfectly capable to run both functions, microservices, and monolithic applications alike. Anyone familiar with this? I think we've all been here at one point or another through our career, telling ourselves that we'd be better off if we just rewrote the whole thing. Hopefully using proper technology. I've seen people doing this countless times. I've even been part of doing it myself at least a couple of times, probably more times than I'd like to admit. And one particular time, I was part of a team that was tasked with migrating a legacy system from on-prem to the cloud. And as a team, we were very excited by the task and quickly decided to rewrite the whole application and make it run on AWS Lambdas. And initially, the progress was really rapid. And in just a couple of months, we managed to have something in place that actually did the larger part of what the current production on-premise system did. Success, right? But then a wild integration appeared. And the integrations and edge cases kept surface. Things we didn't even know about when we got started. And let me tell you, we really, really wanted to get that application out the door and into production. But with all of these unknowns without all of these unknowns covered, it just wasn't possible. And after about a year, we finally had something in production. But we broke both time, schedule and budget. So, with that said, what should we have done differently? It's always easy to answer these questions in hindsight, but first off, we should probably have used the strangler pattern. And because a big rewrite is seldom, if ever, the solution to anything. And the preferable solution is as simple as it's elegant. And instead of the rewrite, we should have set up a router or load balancer. For example, AWS own application load balancer or traffic. Our next step should have been to take the whole application without making a single modification and move it into a virtual machine in the cloud, just without touching it. And after that, we'd be able to slice off layer of features one by one into serverless microservices or Lambda functions, prioritized only by their business value and by what frequency they need to change. If we at any point would decide to abandon our decoupling initiative, we would just be able to leave it running without any additional cost or work needed. With the solution or the path we took, that's just not possible. We'll have to keep developing it until we hit some kind of feature parity with the production system. So just to illustrate this, put a router or load balancer in front of the legacy monolith, split out functionality either into microservices or into lambdas, and keep repeating on that. And as you keep repeating and split off more and more, your legacy application or monolith will shrink until you finally have no code left in your legacy application and can just eliminate it altogether. And hopefully you'll be in a better place than you were before you got started. But this is, of course, no magic silver bullet, and your mileage may vary. But out of the different patterns and reference architectures I've examined, evaluated, or tried this far, this by far qualify as the most powerful one. And the risk is low. You maintain all your current functionality while still being able to deliver rapidly and move chunks out of the monolith as needed. And if there's one single thing that I'd like you to take with you from this session, this is probably it. But there are other considerations as well when you think about or start going serverless. For example, execution time. And I was at a conference a couple of years ago and did a talk on Azure Functions. And when it was time for Q&A, one guy immediately raised his hand and explained that he was running a set of workloads, somewhere between 20 and 80, complex calculations. And each of these calculations could take about 10 minutes or so. He then continued to explain how he had tried Azure Functions, but been unsuccessful in getting his workloads to run with any degree of stability or reliability. And sometimes the functions he deployed just timed out. And he wanted to know whether I had any suggestions as to how he would get his workload to run as functions. And I'm sorry, but this might come as a disappointment to some of you, but I don't have an answer to that. Or rather, I don't have a good solution for that. I'd even go as far as to say that then going for functions probably wasn't for him. Functions are supposed to be ephemeral, and most cloud providers even insist that no function should ever have an execution time above a couple of minutes. I really don't know about Azure or GCP on this one, but for AWS, they actually kill your Lambda instances after 300 seconds. And I don't even think that's negotiable. So if your workload is anything like this, guys, I'd suggest that you opt either for running your workloads as microservices, or maybe even as a serverless app. And as I said, Azure App Service, Google App Engine, Heroku, or AWS Fargate are all great examples of this that you could try utilizing instead. But if you rely on long execution times, probably don't go for functions. Another thing to consider is concurrency. And if we look at the top three cloud providers, Azure, GCP, and AWS, they all have limits on the concurrency of functions, which might be an issue depending on your use case. Because Azure Functions have a limit of 200 instances per function, although each function may process more than one message at a time, or request for that matter. Google Cloud Functions have a hard limit of 1,000 functions per project and about 10 million function invocations per 100 seconds, roughly 1 million per second on average, per region that is. And AWS has a limit of 1,000 concurrent Lambda invocations per region. And this is supposed to be increasable by contacting the support. I haven't been able to get a number on exactly to what amount, but it should be increasable to some extent at least. Usually, this isn't a problem. It depends a lot on the workload. For most loads, it's unlikely that you'll have more than 1,000 concurrent requests. But With that said, analyze your workload before moving forward and also assess your need for heavy concurrency. I was in a project recently where we had a lot of devices that were to connect to a server regularly and send over health data. And we had about 100,000 devices or so that were supposed to do this each minute. And we had no way of controlling whether they would be batched or just at the exact same time. So without introducing any form of randomness or anything like that, we could almost expect to hit that 1,000 concurrency limit. So if you suspect this might become an issue for you, we didn't, but we know now. Just move your workload to a microservice or run it in a container, managed container or a pod or something. Wow. Coupling. This one has bitten me in the hiney more than once. Composing services out of services or services out of functions, it appears so appealing at a glance. I'm so tempted to do this. But for example, our purchase order lambda and our price calculation lambda, wouldn't they really make a really excellent shopping microservice if composed? Why is this such a bad idea? Well, for starters, the orchestration of such a solution quickly becomes really tedious. Say, for example, that the order service, for each item in the order, should query the pricing service on the price. How would this be done? One item at a time? All at once? How about if you also want to ask the address service about where the items are to be shipped? And then want the pricing service to calculate the cost of shipping? Will we then also need to ask the product service about the dimensions and weight of each item? As you can imagine, this really fast becomes really complicated and usually comes hand in hand with really poor performance. The overhead of all the communication back and forth between the services become painful due to HTTP headers and handshakes and whatnot. And we'll also have to keep the client connected to our composite service or aggregator until the request is finished, which in turn might have a negative impact on our potential concurrency. And we also create a tight request level coupling between the services, as a change to any of the services our aggregate depends on would result in the aggregate breaking as well. So, I think my slides were in a... Sorry. Yeah, we've already talked about concurrency. So just to continue on that, PubSub, asynchronous messaging, and WebSockets are a really nice solution to make sure that I really think this should say coupling, so it's still coupling. And PubSub, async messaging, and WebSockets are really nice to solve coupling issues. Because you might, instead of having a persistent connection that you're keeping open until you finished your workflow or your workload, you could just send a message or send a request, distributed it between services using either PubSub or async messaging. And then when the workload has finished, you could just send a message back to the client using the WebSocket, telling it to update or what the differences was. So instead of keeping persistent connections and doing aggregates and passing messages around while keeping connections open, try to utilize publisher-subscriber patterns, async messaging, and WebSockets to do this in a more asynchronous fashion. This might be a little bit hard to read, but it's a typical TypeScript project. serverless functions, basically. We have a couple of different functions, all with their own DTOs, which serve as their request level interfaces. And we also have a large amount of shared libraries beneath. And these could be both business-oriented or technical. And this might look really appealing at a glance. I know for starters that I've done this multiple times. Really enjoyed splitting out the business functionality and everything reusable into libraries and just hands off. But if we were to deploy this into a serverless environment, it would probably look a lot like this. What do we have here? Well, we've basically recreated our monolith 3 times. Once for the order, once for the shipping service, and once for the prices. Because by extracting our common logic into libraries, we make sure that the exact same code is included in each service that needs to use it. So we basically multiply our code into 3 different deployed services. So I was under the impression that this was where we were going. Nice, clean silos without any tight coupling. Which gets us on the topic of code sharing. Most of us have been taught all through our studies and for the entirety of our time as professionals that code should be kept dry, almost to any cost, and that we should avoid code duplication. For microservices, lambdas, and serverless in general, I'd argue that it's quite different. Code duplication in many contexts, probably most, is preferable to introducing common libraries. You might ask, why? Well, because it introduces unnecessary coupling and dependencies, right? A change to the HTTP request handling library suddenly cascades through all our HTTP-enabled services, even though they might have nothing to do with each other at all. And only one of them might be driving the need for that change. You should, of course, still try to keep the code dry inside your specific service, but across services, I'd say that in my experience, that's a recipe for unnecessary downtime, deployment durations, and service quality degradation. And looking back at scaling and concurrency, how on earth would we expect anything where we share code to scale properly? That would force us to scale each function or service regardless of whether the rest of the service would benefit from it. So say that we have some kind of tax or VAT increase library that we run on all our orders for Swedish customers just to add the VAT to their orders. And we put that in a service or in a library, and we reuse that between multiple contexts or multiple services. If that part of the code isn't as performant as the rest of the service, then we'll have to scale the whole service to make up for the lack of performance at that specific point. And we'll have to do that for each and every service that utilizes that bit of code. So instead, to avoid this, we utilize a core concept from DDD called bounded context. And if we find ourselves in a situation where we need to share business logic between services, then we most likely either made a faulty design decision when we decided the boundary, or bounded context, of the service, or simply need another service. This VOT calculation library should probably have been a microservice or a function on its own that we could scale independently of all its consumers or users. And we only have 30 minutes here, so this was basically the lessons that I wanted to share with you that have all bitten me in the hiney more than once. And I just like to take a moment to tell you that this should not be interpreted as dislike or criticism against serverless computing. It might be a bit on the negative side, but I truly believe that serverless is the natural progression of cloud-based computing, and that we as developers really need to embrace the chance of not having to care about the underlying hardware or OS, and instead fully focus on the business values that our organizations are set to deliver. So this is rather some think before you act advice, which you of course should challenge while designing your own architecture anyway. If nothing else, then to make sure that you don't waste time exploring a rabbit hole that leads to nowhere, as I've done countless times. Yeah, that's basically it. Thanks.